everyone. In this talk, Shengyou will demonstrate how to use Kotlin as a back-end language for web development. He will use a framework called Ktor to build an API service. We will see how efficient it is. Okay, let's welcome Shengyou.
Okay, hello everyone. Thanks for coming to this talk. Very happy to get a chance to share the topics around Kotlin and Ktor. I'm Shengyou. I'm a developer advocate at JetBrains. I came from a backend developer background, so mostly I focus on the technology that is being used on the server side. Also, I co-organize several open source communities in my spare time. Hope we could meet somewhere in person next time. Today, I will share how to develop an API service using Ktor. Before we get started to Ktor, I would like to introduce Kotlin first. What is Kotlin? It's a programming language that was developed by JetBrains, and we open source it by Apache 2.0 license. It is a general purpose language. That means you can use Kotlin to do almost everything. It is a strong type language and supports both object-oriented programming and functional programming paradigm. You could get more information on Kotlin official website by this link. We developed Kotlin because we need a better language for our product. More than that, we hope Kotlin is suitable for every platform. So we make Kotlin multi-platform. In this graph, we can see that you could use Kotlin on Android development. The Google Android team chose Kotlin as their primary language. Almost every Android developers use Kotlin today. In the bottom left corner, we could use Kotlin on the server side. No matter what JVM framework you use, you could use Kotlin to write a backend service. This is the major part of today's topic. We will discuss more later. In the top right corner, we could develop mobile app on iOS using Kotlin. We have a project called Kotlin Native that could compile Kotlin code to run on iOS device. So you could share code between your Android team and iOS team. In the top left corner, we even have a project called Kotlin.js. If you like strong type language and want to use it to develop front-end things, it's possible to use Kotlin to do that. It sounds crazy, but yes, we can. So what is Ktor? You know when we developing, generally we rely on a framework. Kotlin is the framework that JetBrains made for web development. It's 100% Kotlin. It has both server-side and client-side components. You could use it to develop a website, API, or microservice. You could find out more information on Ktor official website by this link. After we got the basic concept of Kotlin and Ktor, when you develop an API service using Ktor, the overall workflow will look like this diagram. The client, maybe an Android app or a browser, will fire a HTTP request to our server. Our server will install JVM to run Ktor application. In order to store our data, we will connect to any kind of database. I will use H2 for today's demonstration. In order to make our life easier, the Ktor team provide an IntelliJ IDEA plugin for project creation. You could install the Ktor plugin in your IntelliJ IDEA from our plugin repository. After installed, you will see a Ktor option in the new project dialog. Let me demonstrate a little for this section. So this is my IntelliJ IDEA. If you want to create a new project, you can click the File, New Project. You can see I installed the Ktor plugin inside my IntelliJ IDEA, so we got the Ktor option in the left. You can choose your project SDK, your dependency manager, your engine, your Ktor version, also what kind of server-side component and client-side component you want to use. And next, you can enter the group ID, artifact ID, and your project location, then hit finish. Then the IntelliJ IDEA will create a new project for you. As you can see, here is the empty project that Ktor, from a Ktor application. Mostly, we will write calling source code inside our SRC folder. All of today's demonstration will write inside the application.kt file. So I will write all the calling code inside this function, application.module. I will discuss more later. So today we will create a to-do API. The client could read, create, update, and delete a task through our API endpoint. So I will follow the RESTful style to design my API endpoint like this one. We have an API endpoint using HTTP GET to get all the tasks, an API endpoint using HTTP POST to create a new task, another HTTP GET API endpoint to retrieve a task detail, an endpoint using HTTP path to update existing task, and an API endpoint that use HTTP delete to remove a task. Okay, so next we need to design the response format. We will start from a JSON format. So let's put a curly bracket first. Then I will follow the convention to put all the objects into a data field. So let's wrap up in JSON. In our task object, we need a field to store title and description, and also the task status. I will call it completed. And most importantly, we need an ID field to let the system recognize each task by UUID. As we know, calling is a strong type language. So we could represent our JSON object using data class. So let's create a data class called task response. Then we convert all the property and design the data type. So we will have a UUID property called ID, a string property called title, a strong property called description, and also a Boolean property called completed. So, okay, enough preparation. So how do we convert a task response data class into a JSON string? In Ktor, a HTTP request and response will look like this diagram. A client fires a HTTP request to our server. Our server is our Ktor application. It will take the HTTP request, go through all of these features. Each feature has different ability to process action. In our case, to handle JSON object is our feature. After Ktor process all the actions, it will return a HTTP response. The whole process is called one application call. So in order to let our application to have the ability to handle JSON, we will need to install a JSON library called JSON. So don't forget to open your build.gradle file and add JSON into your dependency section. Next, we need to install content negotiation feature in our Ktor application and set up JSON as our JSON serializer and also the deserializer. So I will back to our source code. So I will put the install syntax here and put the content negotiation feature inside the install. And then we will write the JSON setup. Okay, so that's the simple setup for the JSON library. So then we need to define our routing table. So imagine that the web application is like a building. So we hire security at the ground floor lobby. So routing, just like a security, it checks which URI are allowed to pass, what HTTP method are allowed, and what action will perform when the HTTP request pass the action. So we can use the DSL syntax to set up our route. Use a simple get function to define a route and that open a HTTP GET method using API/tasks path. So back to our source code. So I will add our routing table here. In our routing table, we will open a route for HTTP GET method. We set up the path to /API/tasks. So inside our get function, we could make a dummy response for the route right now. So let's use a for loop to generate maybe 10 task response data class. So I will put the title for the ID. So ID, I will use a random UUID in this fake API. And the title, I will give the fake prefix in our title. Also, I can write a fake description. And we can make a completed status. So in this status, we could make a list that put the true and false. Maybe one more false. And then we randomly shuffle it and get the first one. So to make the fake API more dynamic. So that's our text response. And we need a variable called tasks. It's a mutable list that we put task response inside it. And we can add all the task response inside that list. Okay. So back to our slide. So in order, in our get method, so Ktor will pass the application call object to you. So we can use this call object to set up our HTTP response. By using a map, we could put our task object into a data field when we return a JSON string. So back to our source code, we could get the application call object, and we can set up the response for this route. Then we can make a map that we got a data field, and we will map it to our tasks list. Okay. So let's test this route immediately. So we can push this green button in the Add to Ktor to run this application. You will see that IntelliJ IDEA will build the application and run it. The Ktor application, sorry, here's a some bugs. Okay, so let's do it again. Rebuild it. Okay, so you can see that Ktor application will run on localhost on port 8080. So then we need a HTTP client in order to test our application. So let's open up a Scratch file. A Scratch file is a temporary file inside your IntelliJ IDEA. The file does not belong to your project. You can use it as a playground. So let's create a new Scratch file. The file type will be HTTP request. So in this Scratch file, we could write the HTTP method. For example, we use the HTTP get and follow up your URL. So our URL is maybe 1.1.1.1 and 8080. Also, our route is API/tasks. Then you hit run. So the IntelliJ IDEA will fire a HTTP request to our Ktor application. You can see the response in our result window. So you can see that all the task object is fake, is generated by ourselves, and we put all the task object into a data field. So that's what we want. So it's really easy to produce JSON response in Ktor. So back to our slide. So it's time to store our data in the database. So in JetBrains, we developed a SQL library called Exposed. It's also 100% calling built in. It supports two kinds of syntax. One is SQLite DSL, another is DAO. So it's just like an ORM model. So currently, it supports all the major relational database. You could find out more information on GitHub. So as usual, we need to install dependencies before we use it. So open up your build.gradle file, add exposed into your dependencies. And we will use H2 in our application. So don't forget to add H2 driver in dependencies section. So in today's example, I will use the DAO pattern in our example. So in exposed, we could use calling objects to define our tables in the database. The calling object is just like a singleton pattern. Then we need to define an entity class to represent a record in that table. So you can see we use tasks object as a component object in our task entity. So let's create all the columns by referring to our task response. So we will need a title column. We will use varchar as a data type. And the description column, so we will use text data type. A completed column, so we will use Boolean data type. And when we work with database, it's good to record the created date and also the updated date in our table. So we will create both columns in our object and entity. So the next step is to connect to our database. So we have a route and a data class to produce JSON, and we have a table to and the entity classes to represent the data structure in our database. So let's put all the things together to build a real-world application. So how to connect to our database? So we can use a class called database from exposed library, and also when you connect to your database, you need to specify your URI and the driver in your code. So let's back to our source code. I will write the connection string in front of the routing table. So let's use the database connect. So let's give the database URL and the database driver. Okay. And next, we need to create our schema inside our database. So we can use the schema utility to create tables using our tasks object. And also, we need some initial data inside our database. So we can use the same technique that we use to create our fake API. But please do remember that each action should be placed inside a transaction. So you can see there's two transactions in our source code. So let's write the first transaction. We can use the schema utility to create a tasks table. And we open up a second transaction. We can use a for loop to generate a new task entity. So when we generate a new task, we need to fill in the task title. So that will be task number 1. And the description is the task description. And we need to know the completed. We can use the same technique. So we generate a random Boolean value for the completed. Also, we need the created at. So we can use the datetime now to create the current timestamp into our database. And also we need to write the updated at column. Okay, so that's to generate the initial data for our database. So then we should change the fake API into a real one. So we can use the task entity to retrieve data from the database and map it into a task response. So we can open up our source code. So we can change this line. We open up a new transaction, and we can use the task entity to retrieve all the data from the database. And after we retrieve all the data, we could map it into our task response. So we can convert ID into our database record. Also, the title is from the database. And also the description, completed, and that's it. Okay, so we can convert all the task record to the task response data class. That's the converting. So that's almost everything we need to do when we retrieve the data from the database. Okay, so let's test our application. So let's press the green button again and restart our application. Okay, so after our application started, you can see that we create a database, create a table into our database, generate several initial data into our database, and our application is start running. So switch to our sketch file. We can fire the API request again. And as you can see that all the data is from the database, not the fake one. So that's all of our source code. That you can see that you don't need to write too much line of code. Then you can generate an API from your database. So in the end, if you want to finish all the API, we can use all the skills we learned from the previous step to build other API to to receive the task request from our client and write the data into our database, or you can update and specific task data from your client side and update it in your database. Also, you can delete a specific task in your database. Okay. So after you develop your Ktor application, if you want to deploy your application into your server, you can use Jeep that is from the Google Cloud, that it can convert the Ktor into a Docker image. Then it will be easy to deploy and scale on any cloud service, not specific for the GCP. Okay, so to sum up, we know what Ktor is and its application called cycle, including the HTTP request and the HTTP response. Then we know how to open our routing table and respond JSON string to the client. And at last, we integrate exposed SQL library to interact to the database. So the key takeaway is Kotlin is a good fit for server-side development, and Ktor make this really easy and fun. So give yourself a chance to try it and hope you like it. Okay, so the last slide is my contact information. So here is my email, and the QR code is my Facebook account. So if you have any question, please ping me anytime. I would like to help. So thank you very much for attending this talk. Thank you so much.
Thank you for Shenyou's talk. And if anyone have further question, please feel free to contact him. And now I will pass the mic to our Hong Kong Open Source Conference. Okay, thank you.
Okay, thank you.